A reflection of an object is exactly the same as if you put a mirror in front of it. It creates an exact mirror image of the object. Let's take this arrow and we'll put a mirror line there, and we usually use a dotted line to stand in for a mirror. If we reflect the arrow in that mirror line, we get an exact mirror image of the object. You can see this better if we do another mirror line and do another reflection. You'll see that the bits closest to the mirror are reflected on the other side, closest to the mirror. And we can also do reflections diagonally. This is a little bit harder to see where things are going. So let's note some points on our original arrow. And if we look here, we can see that the slope of the arrow is at 90 degrees to the mirror. So let's draw another point 90 degrees out the other side, and we'll connect those two lines, and then we see that that point there would reflect across the mirror through the perpendicular line that joins them. So we can actually do this for a number of points on this arrow, and we can see where those points would be reflected through the mirror. They go through the mirror, perpendicular, and out the other side the same distance, and so we can draw where the arrow would be. Let's have a look at a couple of examples to show how we would construct these in a proper test condition. So we're going to take this triangle and reflect it in the line x equals 3. So first of all we draw that line where x is equal to 3. Then we'll look at the points on the triangle in turn and see how far away they are from that line, the mirror line. And then if we follow through the other side the same distance perpendicularly through the mirror line, we'll see where that point ends up. So that first corner point there ends up at 8, 3. Second one, we note that that is 8 units away from the mirror line, and therefore it's going to be 8 units through the mirror line along the straight perpendicular line that we've already drawn. And finally, the point at the top, again, perpendicular line to the mirror line, through the mirror the same distance away the other side, and we can see where that point is. Then we can connect up the lines and draw our triangle. And that's the exact mirror image of the original triangle in the mirror line x equals 3. Let's try a harder example. Let's do a sloping line this time. So we're going to reflect a triangle again in the line y is equal to x. We use a triangle so we can see the shape and which way the individual points are going. It's a lot harder if we're using a square or a rectangle. We draw our line in, y is equal to x, and we start looking at each point in turn again. We'll draw a line perpendicular to the mirror line and then the same distance across the other side. And for this it's always best to use a protractor and a ruler to make sure you're getting the angles and the distances correct. Take the second point, perpendicular line, through the mirror for the same distance, draw the point. And then finally the third line is from the top point through the mirror line, and we can now join up those dots and draw our triangle that's a mirror image of the original in the mirror line. If you turn your head to the right, you'll see it a lot easier that that is a mirror image of the original triangle in the mirror line. Obviously if you're doing this on a piece of paper, you can turn the piece of paper so that the line is horizontal or vertical, and that might make it easier for you to do these problems. It's always useful to remember that when doing a lot of different problems in mathematics, you can always turn the page round to make the problem easier. Of course, you might also be asked the question the other way around. You're given two shapes and you're asked which line is the shape reflected in. You've got to find the mirror line. So here's two triangles, and what we're going to do is we're going to draw from each of the points to the corresponding point on that triangle. So we'll do the one from the green dot first at the top, connect those up, then each of the others in turn, and then what we're going to do is we're going to find the centre of each of those lines. Now you can do this with a ruler if you've got an accurate enough ruler, or if you want to make sure it's completely accurate, you can use a pair of compasses and use the technique of drawing a perpendicular bisector to a straight line. You can see how to do this in the video that's under 2D shapes and constructions. So we're going to find the middle point of each of those 3 lines, and once we've found those, we can draw a straight line that connects those 3 center points, and that is the mirror line that we've been looking for. It's halfway between each of the points on the 2 triangles, and that line is y is equal to minus x. Again, you can make this task easier by turning the page round so that the mirror line is either horizontal or vertical, whichever suits your way of working. So finding a mirror line is quite simple. Find some corresponding points on the shapes we've been asked to that have been reflected, and then find the center points of lines that join those corresponding points. Draw the mirror line through those center points, and then, using your knowledge of graphs, write down what the equation of that line is.